Okay, implicit differentiation with partial derivatives. Okay, so what they want right here, they gave us, they gave us a three variable function, and they want us to find the partial z with x at 1, 1, 1. Okay, so it's kind of confusing because when we did it in Calc 1, there were only two variables and we didn't have to worry about anything. So what you'll probably get confused at doing is what's a constant, what's not. So hopefully we'll clear that up. So let's look at the first term. So the first term, what do we got? We have x and y. Well, in this case, x is the independent variable and y is actually just going to be a constant. So the first term, the derivative, is just y. Okay. Now the second term, we got z cubed multiplied by x, but we don't want to treat z cubed as a constant because it's actually the dependent variable. Okay, so what we're going to do is we're going to go ahead and take its derivative, but we're going to also write we're going to write d or partial z partial x by it. Okay, just like we used to do in Calc 1. And furthermore, this is a product. Okay, that's a product of derivatives. So we just use the product rule on it. So if I do that, I'm gonna have to tack on the x back there as well. Okay, and I'm still not done yet. I still got to add x prime, which is just 1. Okay, then regular f, which is z to the third. So that was probably the trickiest part of this problem. Now the next part, what do we got? Well, we've got the dependent variable, and then we've got basically a constant. So we could just write this out here like that, and then same thing. We'll just write dz dx, and of course 0 is just 0. Okay, so let's see if we can't clean this thing up a little bit. So we got y plus 3z squared x dz, actually it's partial z. Actually, I don't care, you can call it dz dx if you want to. Okay, so next thing I can do, I can move over these guys. Actually, okay, I'm going to subtract y, and I'm going to do this all in one swoop. And I think I'll do it in blue, just so it doesn't get confusing. I'm just going to move the y and the 3 over on the other side of the equal sign, and at the same time, I'm going to factor out the partial z, partial x. Okay, so am I still on the page? Okay, all I gotta do is divide by that. And there I go. So I think, let me get another piece of paper. Feel free to just kind of take a look at that while I'm copying everything down. And I just ran out of paper, so now they wanted us to evaluate this thing at the point 1, 1, 1. Okay, so if we plug everything in, we should just go ahead and get it. So that's a y, is it? Yeah, it's a y. So it's -1 minus 1 cubed times 3, and 1 squared is just 1, so that's just how I'm going to write it. And what do we get here? We get -2 over 3 minus 2 is 1, so Oh my god, I did that whole thing without even being on the paper. I apologize sincerely for that. Okay, so there we go. That's I mean, that's all I did. I just plugged everything in right there. So sorry for not being on the paper, but you know, we just came out to 2. And really, you know, the hardest part about this problem was probably, you know, what do I do? You know, do I treat the z to the third as a constant? You know, something like that. So maybe I'll dig up another example here. Yeah, I got about 4 more minutes on here, so I think I might be able to, might get one going. I don't know. So let's try it. Let's go x minus z plus y. Okay, this time they want dx dz. Okay, so let's see here. So partial x with respect to z, that's no problem at all. That's just actually no. Let's save this for the next video, okay? Because I want to show you something on this one.